ठीक है
लोगों के चार्ज पे चश्मा दे Okay, so welcome back dear students. We were solving problem. Question number 2 it was, and in that question I am reading the question. A pre-stressed road bridge of span 10 meter consists of a 380 mm thick concrete slab is post-tensioned with parallel cables. Force in each cable at transfer is 365 kN. Bridge is required to support a uniformly distributed load of 25 kN per meter square. Tensile stress in concrete are not to exceed 0.7 MPa at any time. Check suitability of sectional modulus. How did we verify the suitability of section modulus? We determined the sectional modulus required from these equations. The loss factor is given, there is 20% loss, so it was 0.8. We assume the width of slab as 1 meter, the depth of slab is 380 mm, so the cross sectional area was available, the self-weight is determined, span is available, moment due to the self-weight was determined, the imposed load is also available in terms of kilonewton per meter square, that is converted into kilonewton per meter by multiplying by the width, that was 1 meter. The imposed load is determined, moment. Then FTR, the range of stresses corresponding to the top fiber. FCW minus eta FTT is determined. Permissible values of stresses in compression and working. So for that we are having the curve available in the code. From that FCW was determined. Eta is available. The permissible values of stresses in tension and transfer were given. Everything was substituted here. We were having the value of FTR. So ZT required was determined and it was compared with the value of ZT provided. Similarly, the ZB required was determined and it was compared with the Z provided, and it was found that the sectional modulus provided corresponding to the top and bottom fiber is more than the sectional modulus which is required for the safety of top and bottom. So the conclusion was, whatever sectional modulus provided, it is safe. The second part of the question was, calculate maximum horizontal spacing of the cables and their distance from the soffit of the slab at mid-span. So the second part of the question, calculate maximum horizontal spacing of the cables and their distance from the soffit of the slab at mid-span. How did we determine the maximum horizontal spacing? So for that we have determined the pre-stressing force required for 1 meter wide slab. As it is a rectangular section, the ZB and ZT is same, so that was taken common, cancelled, and the equation was reduced to A by 2 in bracket F inferior plus F superior. So F inferior and F superior were determined corresponding to the Z value provided, whatever section modulus was provided, that was used in the calculation. F inferior and F superior were substituted and the pre-stressing force was determined. This is for 1 meter wide slab. But what is the force that is carried by one cable? 365. So it is 365 divided by 3019.1 multiplied by 1000, that is the width, right? And we have got that the spacing between the cables must be 120.89 mm center to center. So that part was solved. What was next part? To determine the eccentricity. How the eccentricity can be determined? The eccentricity can be determined from this equation. So determine the eccentricity. It is asked in the question. The question is, calculate maximum horizontal spacing of the cables. So that is 120.89 mm center to center. And their distance from the soffit at mid-span. So that is nothing but the eccentricity. Now get the value of eccentricity. How you can have the value of eccentricity? Eccentricity can be determined from this equation 10. So eccentricity is equal to ZB ZT F inferior minus F superior divided by A ZB F inferior plus ZT F superior. As it is a rectangular section, Z can be taken common, that can be cancelled. So one of the Z will get cancelled. It is Z upon A in bracket F inferior minus F superior divided by F inferior plus F superior. This will be the equation. It is rectangular section, so Z is BD square by 6, A is BD, so that will get cancelled. It will be D by 6, it will be 380 divided by 6 in bracket F inferior minus F superior. F inferior is 21.52 minus F superior is minus 5.634 divided by 21.52 minus 5.634, and we will get the eccentricity. So how much is the eccentricity? What must be the eccentricity of the cable at center? Question was to check the sectional modulus, that was verified, it is safe section. Then you were supposed to determine the spacing between the cables. So for that we have determined the pre-stressing force. Then the force carried by one cable was available. We have determined the spacing between the cables. Now we are determining the eccentricity of the cable at mid-span. So this equation will give us what must be the eccentricity at mid-span. It is 108.256. Okay, thank you. 108.256 mm. This is the eccentricity, and obviously below the neutral axis. Now, the further part of the question is locate safe cable zone. Safe cable zone is nothing but it is the range or it is the area within which the cable is to be provided such that there shall not be any kind of cracking because of tension or compression. It must be a safe section. What are the vertical limits within which the cable can be provided? So what we will do at mid-span? Now we are solving for safe cable zone. Cable कहाँ provide करना चाहिए? What are the limits or the boundaries at mid-span? See, these are the two equations, and I have told you we were having two equations for the eccentricity must be less than or equal to. We were having two equations for the eccentricity must be more than or equal to. जो दो इक्वेशन थे फॉर eccentricity must be less than or equal to, उसमें से मैंने बताया था the equation which is corresponding to the bottom will give us the critical answer. Similarly, eccentricity must be more than or equal to. There were two equations. A equation which is corresponding to the top fiber, bottom fiber will give the eccentricity, right? Limits, the critical values. So now use this first equation for at mid-span. Eccentricity must be less than or equal to. What is the value of ZB? Now you have to develop all these properties first. ZB is equal to B D square by 6. Get the value of ZB. What you require is the value of P. How much is the pre-stressing force provided? 3019 point. कितना था? 3019 point something. P. FCT was available. ZBA. Area is 1000 into 380. The moment due to self-weight was determined. What we require next is the pre-stressing force that is available. Eta is 0.8. The value of FTW minus 0.7. Movement due to self-weight, movement due to imposed load. So we must know all these values so that we can substitute the values here and we can get the required answers. So now you give me these values. What is the value of ZB? The sectional modulus ZB and ZT is same. Z is BD square by 6. So please give me the answers. I will write here and we will get the required values for the limits for the eccentricities. The eccentricity must be less than or equal to. Till you do it fast. Then we require these terms ZB upon P FCT, ZB upon A, MS upon P, so that I will write the values here. I will write these 4 values here and we will get the limits within which the cable is to be provided at mid span. How much was, what is the value of section modulus provided? 24.07. Thank you. So it is equal to 24.07 into 10 raised to power 6 mm cube. Pre-staging force. Till you do it fast. I am expecting you to use calculator. Do it fast so that we will have the answers. Pre-staging force, FCT, all those values are already available with you. अभी हमने calculation में use किया है सब. Now I don't remember. Pre-staging force, FCT, MS, MI, ये सब values रहेगा अभी आपके पास. Right, FCT is minus 0.7. FCT, permissible values of stresses in compression and transfer. How that can be minus 0.7? Because it is permissible values of stresses in compression and transfer. Compression के stresses minus में कैसे रहेंगे? Is that right, Raina? Okay. 118.75. Thank you. So it is 118.75 kilonewton meter. आप लोग कैलकुलेशन भी कर सकते हो इन पैरेलल. Give me the values. I don't know. FCT is 2.3 per watt. Don't ask me. I expect you to answer. It is 312.5. Okay, impulse moment 312.5. Now FCT, permissible values of stresses, FCT, is that 21.34? Okay, fine, thank you. So that was 21.34. We had determined from the curve. Now put everything here in the equation, ZB upon P, FCT. How much this value is? ZB upon P FCT. ZB is available, P is also available. FCT is also available. How much this value is? ZB upon P FCT. Then give me the answer for ZB upon A. Then give me answer for MS upon P. $170.134. What is that? Is that ZB upon PFCT 170.14? Okay, fine. Thank you. First term. What about the second term? ZB upon A? That must be D by 6. 380 upon 6. Somewhere 60, 62 आना चाहिए. 63.34. Okay, thank you. So it is 63.34. What about MS upon P? Okay, thank you. ZB upon A is 63.33. 3334. Okay. Now what about MS upon P? The third term. $38.19. Okay, thank you. So it is equal to 38.19. Now put everything here in the equation. 170.14 minus 63.34 plus 38.19. So eccentricity must be less than or equal to 39.33. Okay, 39.33. 38.19 correct नहीं है. Okay, so it must be 39.33. ठीक है, 39.33. So it is equal to 39.33. So it is 39.33. So eccentricity must be less than or equal to 146.13. अच्छा, अनन्या कह दी है 116.13. So which of the two is right? Is it 146 or 116? 70. ये कितना होगा? 40. 210 में से 60 गया. 210 में 60 140 के आसपास रहेगा शायद. 210 में से 60. Okay, fine. So it is 146.13. Thank you. So it is equal to 146.13 mm. So eccentricity must be less than or equal to this. Now, from the second equation, eccentricity must be more than or equal to eta PE by FTW. How much this is? ZB upon P eta FTW. Get this value. MS upon P is already available. Get MS upon eta P. यहाँ जो भी वैल्यू रहेगा that will get multiplied divided by only eta. Next third term MI upon eta P, and the fourth term ZB upon it, that is already available here, the fourth term. Now give me the answers for these terms, first, second, third and fourth. Minus 6.98, what is that? That is first term. ZB upon P minus 6.98. Okay. What about this second term? MS upon P is already available. You need to just divide it by eta. Eta is 0.8. तो थोड़ा सा बढ़ जाएगा ये 80 के आसपास होना चाहिए समथिंग. So what about the second term, ms upon eta p? चलिए मुझे फटाफट आंसर दीजिए. 49.17, हाउ कम डेट विल बी ms अपॉन p? पहले कितना आया था ms अपॉन? अच्छा 30 कितना था? 39. ओके 40 डिवाइड बाय 0.8. अच्छा ठीक है 49.17 डन. सो इट इज 49.17 थर्ड mi अपॉन eta p. वन 40 के आसपास आना चाहिए शायद थर्ड टर्म. हाँ यू आर राइट 39.33 डिवाइड बाय 0.8 129.38. ओके इट इज थर्ड टर्म 129.38 and the fourth term is same 63.38. So eccentricity must be more than or equal to minus 6.98 plus ms upon eta p 49.17 mi plus 129.38. It is minus zb upon a, so it is minus 63.34. So eccentricity must be more than or equal to eccentricity must be more than or equal to, the fourth term is already we are having zb upon a 108.23. okay done. So 108.23, it means that if we are providing see, say this is the longitudinal view, say it is supported here, say this is the center line or the neutral axis, say this is the center line of the slab. So what must be the eccentricities at the center? Eccentricity must be more than 108. So this is 108. And eccentricity must be less than or equal to, how much that was? Less than or equal to कितना था? 100 and eccentricity must be less than or equal to कितना था आंसर? थोड़ा बेटा ऊपर की चैट में चलो. 146.13. ओके थैंक यू. 146.13. okay, so this is the limit within which the cable is to be provided here at the center. At center, this is the longitudinal view, this is the center. So eccentricity must be within this limit 108.23 and it is 146.13. And what about at support? What must be the eccentricities? Now eccentricity must be less than or equal to, now this equation again, but now I will be using at support. The only difference will be at the support, the moment because of self weight will be 0 because it is a simple support. So this term will always be there. How much this answer was? ZB upon PFCT. How much was the answer? ZB upon PFCT. ZB upon PFCT. How much that answer was? How much was the first term value? 140.13. It is 140.134 because this is already available, minus ZB upon A. ZB upon A was 63.34. So eccentricity must be less than or equal to. What is the limit? much was the first term? What was the first term? जरा चैट ऊपर बताओ. और ऊपर हाँ फर्स्ट टर्म वाज 170.134. चलो नीचे आ जाओ. अच्छा, so the eccentricity is final. Is it right? This is not 140. ये कितना था? 170 था क्या? 170.14. Okay. So the answer is eccentricity must be less than or equal to 106.79. And now eccentricity must be more than or equal to ZB, eta, P, FTW. It is already available here. Minus 6.98. Moment because of self-weight will be 0. Moment because of imposed load will be 0. And this is minus ZB upon A is minus 63.34. So it is minus. So how much it must be? Minus 6.98 and minus 63.34. Minus 70.32. Minus 70.32. See what it indicates. Eccentricity कितना रहना चाहिए? Must be less than or equal to this. So this is the eccentricity. This is 106.97. It must be less than that. And this negative only indicates that the eccentricity is on the other side. We had developed all the equations assuming that the eccentricity is below the neutral axis. But here I am getting negative value for the eccentricity. If this eccentricity we are getting with minus, it only indicates that the whichever side we had started with the assumption, the eccentricity that was assumed as below the neutral axis is not right, but the eccentricity is on the other side. So it is on the other side 70 point. Here above the neutral axis is 70.32. So here now we have got a range within which the cable can be provided. This is the, we have to join by the parabolic curve. We have to join the upper limit here with this upper limit, the lower limit here with the lower limit by the parabolic curves. So whatever we have got here, this zone, it is the limits within which the cable is to be provided. It is the limit in which the cable is to be provided. So, see, how much was the eccentricity required? 108.256. How much it can be provided here? 108.23. So इससे थोड़ा ज़्यादा है. It is 108.256. It is all right. This is the lower limit. Lower limit से थोड़ा ज़्यादा रहेगा. This is okay. Upper limit से कम है. So this is what the optimum eccentricity and the pre-stressing force was determined earlier. So the pre-stressing force was such that the eccentricity is within these vertical limits. Support पर भी हमने vertical limit निकाला है. Is it possible to provide a straight cable with this much of eccentricity? 108.256. हम एक straight cable provide कर सकते हैं क्या? Is it possible to provide a straight cable with eccentricity 108.256? Will somebody answer this? Is it possible to provide a straight cable maintaining the same eccentricity at support as well as at mid-span equal to 108.256? No, you are right, Raina, but I want explanation. Why not? Because the eccentricity at the support maximum that can be provided is 106.97. You are also right, Mr. Mas. Correct. Because at the support the maximum that can be provided is 106.97. Whereas if I provide 108.256, the support section we may get cracks and the element will fail in the serviceability of cracking and maximum compression. So here a straight cable with eccentricity 108.256 cannot be provided. What we will do here, we will provide a curved cable, a parabolic cable. The only thing is it must lie within this range. Okay, this will do. If I provide a cable like this, it is all sufficient. Say it is concentrated support and having a maximum eccentricity is equal to 108.256. And it is concentric here. It is possible to provide a parabolic cable. You were supposed to provide parallel cables so that the cables are parabolic and they are parallel. The cables are parabolic. This is one cable. This is the longitudinal view. Behind this we are having another cable, one more cable, so on. As long as the width of the slab is. जितना स्लैब का विड्थ रहेगा अकॉर्डिंगली इसके पीछे एक केबल ऐसे चलते रहेंगे एट ए डिस्टेंस ऑफ 120 mm center to center. So this is how first we had verified the sectional modulus, then we had determined the spacing of the cables, then we have determined the eccentricity that is to be provided at center, then we have determined the safe cable zone, and we have placed the cable within the safe cable zone, and this is how we have to design कि सेक्शन ठीक है या नहीं है, विस्टेजिंग फोर्स कितना रहना चाहिए, एक्सेंट्रिसिटी कितना रहना चाहिए, एक्सेंट्रिसिटीज के लिमिट्स क्या है, such that it must be safe in limited state of serviceability. So this is how a twistless concrete section can be designed. Now we will move to question number 3. The question number 3 is a post-tension unsymmetric I section having the following properties. Now it is a post-tension section unsymmetric I section having the proper use over a 3 meter long bridge girder. Span is over a 30 meter long span. It is a bridge girder. The thickness of top and bottom flange is 200 mm and 250 mm respectively. The thicknesses, okay. 200 mm is the thickness. The width of top and flange is 750 and 450. Okay, this is 750. The width of top and bottom flange. Width of top flange is 750. The width of bottom flange is 450. The thickness of the web is 150. Fine. The thickness of web is 150 mm. The overall depth is 1000 mm. Okay, fine. The overall depth of the section is 1000 mm. And area of section. ठीक है, okay, very good. ये हमारा काम थोड़ा हल्का कर दिया है. The cross sectional area is not directly given here. It is 345,000 mm square. नहीं दिया रहता तो सेक्शन से हमको डेवलप करना पड़ता है एरिया का वैल्यू. ZT is equal to 95 to 10 raised to power 6 mm cube. ZB is equal to 75 to 10 raised to power 6 mm cube. ये भी अच्छा कर दिया है. The sectional modulus corresponding to the top and bottom fiber is given. अगर sectional modulus नहीं दिया होता तो फिर हमको पहले न्यूट्रल एक्सिस लोकेट करना पड़ता, इसका मोमेंट ऑफ इनर्शिया डिटरमाइन करना पड़ता, फिर मोमेंट ऑफ इनर्शिया से इसका सेक्शनल मॉडुलस डिटरमाइन करना पड़ता. इज दैट राइट? तो उसमें हमारा काफी टाइम लॉस हो जाता. बट इट इज एक्सपेक्टेड दैट कि स्टूडेंट ने इंजीनियरिंग मैकेनिक्स, स्ट्रेंथ ऑफ मटेरियल में ये सब प्रॉपर्टीज डेवलप करना सीख गए हैं. नाउ वी आर मेकिंग यूज ऑफ दोज प्रॉपर्टीज. इट इज अनसिमेट्रिक आई सेक्शन, डायमेंशन इज अवेलेबल, area is given, the sectional modulus corresponding to the top and bottom fiber is also available. Now what you are supposed to do? The position of the center of the section is 440 mm from the top. Okay. So here is the neutral axis. This I will call as YT. It is 440 mm. So how much is the value of YB? Y will be equal to 560 mm because the overall depth is 1000 mm. The position of neutral axis from the extreme top fiber is given. अगर ये वैल्यूज नहीं दिया होता तो फिर हमको डेवलप करना पड़ता, 5-10 मिनट तो हमारा ये सब प्रॉपर्टीज डेवलप करने में निकल गया होता. ओके, आई सेक्शन डायमेंशंस दिया है, क्रॉस सेक्शनल एरिया दिया है, section modulus corresponding to top and bottom fiber is available. The position of neutral axis is also given. It is a girder of a bridge. Girders are nothing but the heavy beams. Girders are nothing but the heavy beams. जैसे हमने स्टील स्ट्रक्चर में भी देखा रहेगा, प्लेट गर्डर, that is nothing but a heavy beam which is subjected to greater magnitude of loads. So this is the girder. Consider type 1 element. What does it mean by type 1 element? Type 1 element का क्या मतलब रहेगा? The value of FTT must be equal to value of FTW must be equal to 0. Because this is type 1 element. Type 1 means no tensile stresses are permitted at transfer as well as at working. So FTT is equal to FTW is equal to 0. You are right. So FTT is equal to FTW is equal to 0. Use M55 concrete. So the grade of concrete is given M55. FCI is equal to 0.7 FCK. चलेगा ऐसे. FCI, the strength of concrete at transfer, is 70% of the strength of concrete at service और characteristic. मिनिमम FCI का वैल्यू कितना रहना चाहिए? FCI का वैल्यू मिनिमम 0.5 टाइम्स ऑफ FC का रहना चाहिए. ये कोड में दिया है, हमने रीड किया था सुबह को. The minimum strength of concrete at the edge of transfer must be 50% of the characteristic compressive strength of concrete, 0.7 times of FCK. Imposed uniformly distributed load is 4 kilonewton per meter. Okay, WI is equal to 4 kilonewton per meter. Done. Verify suitability of section. You are supposed to verify suitability of section. ठीक है, हम ये वेरीफाई करेंगे. Determine optimum pre-staging force and corresponding eccentricity. Also locate safe cable zone. Take eta is equal to 0.85. Eta is equal to 0.85. Determine P, determine E, and get the safe cable zone. That's all. क्योंकि ये चैप्टर में मैक्सिमम यही पूछ सकता है, सेक्शन ठीक है ये नहीं है, प्री-स्ट्रेसिंग फोर्स कितना चाहिए रहेगा, एक्सेंट्रिसिटी कितना चाहिए, सेफ केबल जोन लोकेट कीजिए. राइट, ये पूरे चैप्टर में यही चलते रहेगा. दैट्स व्हाई फर्स्ट वी हैव डेवलप्ड ऑल दीज इक्वेशंस. नाउ वी विल मेक यूज ऑफ दीज इक्वेशंस एंड वी विल सॉल्व द प्रॉब्लम. इट इज अ सिमिलर काइंड ऑफ थिंग एज वी हैड डन अर्लियर. How to verify the section modulus? Yes, section modulus will be safe if ZT provided is greater than or equal to ZT required. Similarly, if the ZB provided is greater than ZB required, then it is safe. Right? ये section safe कब रहेगा? Section suitable कब रहेगा? जब sectional modulus provided is more than the sectional modulus required. Okay, so now we will determining the sectional modulus required because the provided value are already available here. These are the sectional modulus provided. Now determine the sectional modulus required. ZT required must be more than or equal to 1 minus eta. 1 minus eta, what is the loss factor given? 0.85 minus 0.85. ms, moment because of self weight. How will you get the moment because of self weight? Self weight intensity, the cross 345,000 into 10 raised to power minus 6 I will do, because it is given in mm square. We are multiplying with 10 raised to power minus 6, so that it will get converted into meter square. Multiplied by 25, the self weight, the unit weight, I will get the self weight intensity. What is the self weight intensity? Then get the moment because of the self weight. WL square by 8, the span is available 30 meter. So first you get the self weight 345,000, that is in mm square, multiply with 10 raised to power minus 6, convert into meter square, multiplied by the unit weight, that is 8.625. Okay, it is 8.625 kilonewton per meter. What is WL square by 8? The span is 30 meter. WL square by 8, 970.3125. So it is 970.3125. 970.3125 plus, what about the moment because of imposed load? The imposed load is 4 kilonewton per meter. Get of imposed load 4 into 30 square by 8. 450. So that will be 450 kilonewton meter. So it is plus 450. This will get multiplied by 10 raised to power 6 divided by. What about this? FTR. How to get the value of FTR? FTR is equal to permissible values of stresses in concrete at working. Permissible values of stresses in compression at working. So what is the value of FCW? Where to get the value of FCW? Refer IS code. Refer IS code. Get the value of FCW. We need to refer for working. It means that it is figure 7 we need to refer. It is M30, it is M60, and it is 0.41 FCK, it is 0.35 FCK. So how much it will be corresponding to M55? 0.36 FCK. Is that right? Is that correct? Simple interpolation at working, that's why I am using that particular curve. At working stage we require. So it is 0.36 FCK, simple interpolation. 0.41 and 0.35, there is a difference of 0.06. So 30 से 60 में भी difference, अगर 5 का हम देखेंगे तो it is 6 times. So it is just 0.01 increase, 0.36 FCK. So what is the value of FCW? The permissible values of stresses in compression at working, FCW, 0.36 FCK. FCK is 55. It is given in the question. M55 is to be used. So it is 0.36 into 55. What is value of FCW? Please do calculations in parallel to me. Keep replying. It is 19.8. Thank you, Mayur. So it is 19.8. Eta is 0.85. What about the value of FTT? FTT is 0. So this is nothing but 19.8 only, because it is 19.8 minus 0.85 into 0. So that is equal to 19.8 only. So use here 19.8 FTR and get the value of ZT required. And we have to compare the value of ZT required with the ZT provided. The provided value of sectional modulus is already available. It is 95 into 10 raised to power 6. So now get the value of ZT required and compare it with the provided value. If the provided is more than the required, it is safe. 30.078. Thank you. So the required value is FCW. अच्छा FCW कितना है? FCW was 19.8. It is 30.07. It is 30.078 is the required, and it is less than the provided value of ZT, 95 into 10 raised to power 6. This is ZT required. This is ZT provided. So the provided value is more than the required value, so it is safe. टॉप में क्रैक नहीं आएगा. इट इज सेफ इन लिमिटेड स्टेट ऑफ सर्विसिबिलिटी फॉर क्रैकिंग एंड मैक्सिमम कॉम्प्रेशन. टॉप सेक्शन इज द टॉप फाइबर इज सेफ. नो आई नीड टू वेरीफाई द बॉटम. सो फॉर बॉटम अगेन ZB required. How much it will be? 1 minus 0.85 into 970.3125 plus 450 into 10 raised to power 6. The numerator is same, divided by. What about the denominator? FBR. FBR is nothing but 0.85 into permissible values of stresses in compression at transfer. Now, how to get the permissible values of stresses in compression at transfer? Use the curve for FCT. Which curve we will be using? There are two curves available for the transfer. One is for post tension and another is for the pre-tension. The given problem or the given section is a post tension section. So we need to refer 8A. It is M30. It is M60. It is 0.54 FCI and this is 0.37 FCI. So get the value corresponding to M50. How much this value will be? First you get in terms of FCI. फिर हम रखेंगे FCI is equal to 0.7 times of FCK. That we'll put afterward. First you give me the answer by simple interpolation. M55 का corresponding value क्या होना चाहिए? Not M50, it is M55. 55 grade of concrete we are using now. Given in the question is M55. Permissible values of stresses in compression at transfer, FCT, in terms of FCI. Simple interpolation. 0.54, 0.37 for M30 and M60 correspondingly. Get the values corresponding to M55. 0.398. Okay. So it is 0.398 FCI. And what is FCI? FCI is equal to, so I can write FCT is equal to 0.398 and this FCI is equal to how much given? 0.7 times of FCK. So it is multiplied by 0.7 into 55. So get the value of FCT. Permissible values of stresses in compression at transfer. 0.398 FCI and FCI कितना है? 0.7 times of FCK. So what are the permissible values of stresses in compression at transfer? $15.323. Okay. So it is 15.323 FCT is equal to 15.323 minus FTW minus 0. Is that right? That is FBR. So get the sectional modulus required corresponding to bottom fiber. Get the sectional modulus required corresponding to the safety of, is it top fiber or bottom fiber now? It is bottom fiber we are talking about. 38.866. So it is equal to 38.866 into 10 raised to power 6 mm cube. This is required, and how much is provided? 75 into 10 raised to power 6 mm cube. So is it safe or unsafe? It is safe. The required value is less and the provided value is more, so we can say that it is safe. Acha, that is 45.73. Okay, ठीक है, no problem. 45.7374, that will do. So it is 45.73 or 74. 45.74 into 10 raised to power 6 mm cube. So the required is less and the provided is more. So it is safe. Is that right? Any doubt? (45.74 into 10 raised to power 6). Is it safe or unsafe? बॉटम फाइबर क्रैक नहीं होगा, सेफ है. टॉप फाइबर भी सेफ है. So it is a safe section. This is how we can verify the suitability of section. Is that all right? Is it a safe or unsafe section? Is there any mistake in the solution? It is safe section, okay? It is a safe section. Okay, fine. Thank you. Now, what is the next part in the question? Get the magnitude of pre-stressing force. How we can get the magnitude of pre-stressing force? What is the magnitude of pre-stressing force? P. This is the equation for P. See, it is not a symmetric eye section or it is not a rectangular section. अगर rectangular section रहता है या symmetric eye section रहता है, ZB और ZT same रहता है, and we could have taken common and cancelled that. But it is not same here. It is different. So we have to put the values here. It is 345000. That is A in bracket ZB. What is the value of ZB provided? 75 into 10 raised to power 6 into what you require next is F inferior. Then what you require next is F superior. So get these values, F inferior and superior. What is F superior? FTT. It is type 1 element, so it is 0 minus MS upon ZT. What is MS? MS is available 970.3125. ZT is also available. So get the value of MS upon ZT and tell me the answer. MS upon ZT. MS is available. ZT is also there. Take the ratio and give me the value for MS upon ZT. How much is MS upon ZT? यूज कैलकुलेटर्स, डू इट फास्ट. हमको जो जो टर्म चाहिए वो आप सब कैलकुलेट करते रहिए इन पैरेलल टू मी. बल्कि इफ यू अंडरस्टूड द कंसेप्ट यू कैन गो अहेड ऑल्सो. That is 10.21. Thank you, Osmani. So it is 10.21. So it is F superior. FTT 0 minus MS upon ZT is 10.21. So it is minus 10.21. So it is minus 10.21. Okay. What about F inferior? 1 upon eta. 1 divided by 0.85. In bracket FTW, permissible values of stresses in tension at working, 0 because it is type 1 element, plus what is answer for? अच्छा, MI upon ZB and MS upon ZB. पहले ये दोनों वैल्यू सेपरेटली कैलकुलेट कर लेंगे हम, then we will add MS upon ZB and MI upon ZB. Give me these values separately. MS upon ZB and MI upon ZB. What is that? 3.28. That is not 10.22. Give me these values. MS upon ZB and MI upon ZB. MI upon ZB is 6. Thank you. MI upon ZB is 6. What about MS upon ZB? Okay, thank you. 12.93. So it is 12.93. Now put here 0 plus 12.93 plus 6. तो 12 और 6 18 और एक 19 डिवाइड बाई 0.85, एक 22 के आसपास रहना चाहिए, 21 22, 22.27. थैंक यू. सो इट इज इक्वल टू 22.27. So the F inferior is available, F superior is also available. F inferior is 22.27 and it is minus 10.21. Okay, done. Now we are having all the required values. We can put them here in the equation and we can get the value of the pre-stressing force required. It is A ZB into F inferior 22.27 plus ZT. ZT is 95 into 10 raised to power 6 into F superior. It is 10.21 divided by ZT plus ZB. It is 95 into 10 raised to power 6 plus 75 into 10 raised to power 6. Get the magnitude of pre-stressing force required. ओके हमने इक्वेशन ऑलरेडी डेवलप करके रख लिया है, अभी हमको बस वो इक्वेशन यूज करते रहना है. यू हैव टू रिमेंबर दिस इक्वेशंस. और मैं तो सजेस्ट करूंगा कि याद रखने का जरूरत नहीं है, साला 5 मिनट में डेवलप हो जाएगा. इट विल टेक नॉट मोर देन 5 मिनट्स. अगर आपने 4-5 मरतबा प्रैक्टिस किया तो यू विल लर्न हाउ टू डेवलप द इक्वेशन. जितना याद होता है उतना ठीक है, जो याद नहीं होता है उसको डेवलप करने का. Okay, thank you, Danish. It is 22.3, 22.27. I have used 22.27. I have solved. So, what is the pre-stressing force required now? What is 1.42? वन फोर टू और कुछ आगे भी रहेगा, उतना किलो न्यूटन होगा. अच्छा हाँ, वेरी गुड वेरी गुड वेरी गुड. इट इज मेगा न्यूटन. सो डेट मस्ट बी 1421.19. ओके, एग्रीड. इट इज 1421.19 किलो न्यूटन. ओके, मुस्तफा ने उसको मेगा न्यूटन में दिया था, चलेगा, नो प्रॉब्लम. किलो न्यूटन, मेगा न्यूटन, ओके. सो दिस मच इज द प्रीस्ट्रेसिंग फोर्स रिक्वायर्ड. तो प्रॉब्लम में दिया था पहले चेक सुटेबिलिटी ऑफ सेक्शन, वी हैव वेरीफाइड द सुटेबिलिटी ऑफ सेक्शन. फिर क्वेश्चन में दिया है गेट द प्रीस्ट्रेसिंग फोर्स ऑप्टिमम and get the corresponding eccentricity. How to get eccentricity? Eccentricity we can from this equation 10. So the eccentricity is equal to ZB ZT. ZB ZT are already available. It is 95 into 10 raised to power 6 into 75 into 10 raised to power 6. रेक्टेंगुलर रहता है या सिमेट्रिक आई सेक्शन रहता है तो Z कॉमन रहता है, हमारा कुछ पार्ट कैंसिल हो जाता, बट इट इज अनसिमेट्रिक आई सेक्शन, कॉमन कैंसिल करने का कोई स्कोप नहीं है. एफ इंफीरियर माइनस एफ सुपीरियर. एफ इंफीरियर इज 22.27, माइनस ऑफ माइनस विल गेट प्लस 10.21 डिवाइडेड बाय ए 345,000. ZB 75 into 10 raised to power 6. F inferior into 22.27 minus ZTF superior 95 into 10 raised to power 6 into 10.21. So get the value of eccentricity, right? इसके लिए वो सब वैल्यूज हमने पहले से कैलकुलेट करके रख लिया था. यस, यू आर राइट मुस्तफा, यू आर राइट. मेगा न्यूटन में दे सकते हैं, नो प्रॉब्लम. So what must be the eccentricity? What must be the eccentricity? ZB ZT F superior minus F inferior divided by A ZB F inferior minus plus ZT F superior. So get the value for eccentricity 927.8. Okay. So the eccentricity must be equal to 927.8 mm. This is the pre-stressing force optimum and this is corresponding eccentricity. Is that right? Any problem? Acha, 957, it is not 927. Okay, I will make correction. 957.85. 957.85. 957.85. Okay, is that right? 957.85. Okay, fine. But is it practically possible to provide this much of eccentricity? What is the position of neutral axis from the extreme bottom fiber? It is 560 mm. The position of neutral axis from the extreme bottom fiber is 560 mm, right? This is the neutral axis. This is extreme bottom fiber. How much this distance is? 560 mm. अगर मुझे एक्सेंट्रिसिटी रखना है तो कुछ इसका 50 mm 100 mm मैंने यहाँ पर कुछ स्कोप रखना चाहिए, and that is what the maximum that can be provided. But how much is required here? 957. And what is the eccentricity? The value of extreme bottom fiber from the neutral axis 560. Is that possible to provide practically? No. The eccentricity is going outside of the section. हम इतना एक्सेंट्रिसिटी प्रोवाइड नहीं कर सकते हैं. फिर क्या करना पड़ेगा मुझे? I have to restrict the eccentricity. कितना रेस्ट्रिक्ट करेंगे? कुछ 50 mm, 100 mm का आपको कवर रखना पड़ेगा. So now you suggest me the cover. With reference to that suggested cover, we will recalculate the value of pre-stressing force. ये मुझे पहले से पता था कि ऐसे होने वाला है. Why I was knowing? Whenever such situation arise, क्या है situation? The moment because of self weight is the moment because of imposed load, more than moment because of imposed load. It is 970. And how much was the moment due to the imposed load? 450. जब भी moment because of self weight is more than moment because of imposed load, ऐसा सिचुएशन आता है जब हम ऑप्टिमम प्री-स्ट्रेसिंग फोर्स और उसका करस्पॉन्डिंग एक्सेंट्रिसिटी कैलकुलेट करते हैं. ऐसे होता है कि एक्सेंट्रिसिटी सेक्शन के बाहर चला जाता है. तो अब दैट मच ऑफ एक्सेंट्रिसिटी कैन नॉट बी प्रोवाइडेड प्रैक्टिकली. देन व्हाट वी नीड टू डू इन सच केसेस? वी हैव टू रेस्ट्रिक्ट द एक्सेंट्रिसिटी. कितना रेस्ट्रिक्ट करेंगे? कुछ 50 mm, 100 mm का हमको कवर रखना पड़ेगा. सम कवर वी नीड टू प्रोवाइड. और जितना भी हम कवर रखेंगे, इन रेफरेंस टू दैट वी नीड टू रिकैलकुलेट द वैल्यू ऑफ प्री-स्ट्रेसिंग फोर्स. राइट? ऐसे सिचुएशन कब आता है? ऐसा सिचुएशन हमेशा उस वक्त आता है द मोमेंट बिकॉज ऑफ सेल्फ वेट इज मोर देन मोमेंट बिकॉज ऑफ इम्पोज्ड लोड. व्हेनेवर सच सिचुएशन अराइज, व्हेनेवर मोमेंट बिकॉज ऑफ सेल्फ वेट इज मोर देन मोमेंट बिकॉज ऑफ इम्पोज्ड लोड, सो इन दैट केस इट हैपेंस. तो क्या करना पड़ेगा? से एक्सेंट्रिसिटी, राइट, इट इज मोर देन 560 mm. Not possible to provide practically. Not possible to provide practically. So what we will do? Let maximum eccentricity that can be provided. We are keeping a cover of 100 mm. So it is 460 mm is the maximum eccentricity we are keeping. 100 mm effective cover for the cable. Effective cover for cable. अगर मैंने एक्सेंट्रिसिटी को रिस्ट्रिक्ट किया, now I need to recalculate. Now I need to recalculate the value of pre-stressing force. The magnitude of pre-stressing force is to be revised. How to get that revised pre-stressing force? The magnitude of revised pre-stressing force. The magnitude of revised pre-stressing force we have to get from the equation of F inferior. F inferior is equal to P by A plus PE by ZB. So from here we need to get, it is nothing but ZB plus AE into P divided by AZB. So P is equal to, for calculation of revised value of pre-stressing force. This equation will give us the critical value of the revised value of the pre-stressing force. This equation is the critical equation that will give us the revised value of the pre-stressing force. Right? So, because if we calculate the value of pre-stressing force from any other equation, that is not going to be the critical. From this equation only, whatever value we will be getting for the pre-stressing force revised, that is critical. So F inferior is equal to P by A plus PE by ZB. Simply rearrange the term, get P one side and all other terms on the other side, we get the magnitude of the pre-stressing force. Now use this and get the revised value of pre-stressing force. How much is F inferior? It is already available, 22.27. What is area? 345,000. Into what is the section modulus corresponding to the bottom? 75 into 10 raised to power 6 divided by ZB, 75 into 10 raised to power 6 plus area 345,000 multiplied by eccentricity is 460. The eccentricity is restricted to 460 mm. The eccentricity is restricted to 460 mm with a effective cover of 100 mm and the Pre-stressing force value is revised. Is that alright? 2466. Mustafa has written answer as 2466. Is that right? Will somebody support this answer? 2465.71. Okay, that will do. So the pre-stressing force is 2465.71 kilonewton. It is the revised value of pre-stressing force. The eccentricity is restricted and the pre-stressing force is revised 2465.7. 2465.7. Okay, done. So now the eccentricity provided is 460 mm and the magnitude of pre-stressing force is 2465.71 kilonewton. Okay. Now, what is the next part of the question? Safe cable zone. ये भी पूछा है. Locate the safe cable zone. How to locate safe cable zone? Again, these two equations now. These are the two equations to be used for the safe cable zone. Eccentricity must be less than or equal to ZB upon P. Now keep giving me these answers. ZB upon P, FCT. ZB upon A. Then it is MS upon P. ZB is available, P is available, FCT is available. FCT is 15.323. ZB is 75. Pre-stressing force is 2465.71. Put everything here in the equation. Second, third, give me the three terms. Pre-stressing force must be less than or equal to give me these three terms. First, 466.09. Second, okay, you are right there. 466.08, you are correct. Okay, second, 217.4. Okay, done. 217.4. So it is 217.4. What about the third term, MS upon P? You are right, Mayur. 642.1. What is that? It's a final eccentricity. Okay. Will somebody please give me the third term? MS upon P. Okay, 393.52. 393.52. So it will be 466.09 minus 217.4 plus 393.52. And finally, that is eccentricity must be less than or equal to what is the final answer? Mustafa has given that answer. It is 642.11. Is that right? अच्छा 4 और 4 8 में से 2 हो गया 600 हो सकता है. करेक्ट है. 642.11. Will someone support Mustafa? 642.11. ठीक है. Thank you. So it is 642.11. Now what about eccentricity must be more than or equal to? It is ZB upon eta P into FTW. What is the value of FTW? The permissible values of stress in tension and working. FTW is 0. So this part is 0. Now what about MS upon eta P? MS upon P is available. Only divided by eta. Eta is 0.85. So 393.52 divided by 0.85, you will have this term ms upon p. Third term is mi upon eta p, and the fourth term is zb upon a. So zb upon a is already available. Okay, so the terms are available. Eccentricity must be greater than or equal to 0 plus 462.97 plus 214.71 minus 217.4. So eccentricity must be more than or equal to. What is the answer? How much is the answer? Eccentricity must be more than or equal to 460.28. Okay, thank you. So it is 460.28 mm. Now I will draw this. How it will be? If I will have the longitudinal view, this is the beam. It is 440 from top and it is 560 from bottom. अच्छा, या साला ये तो मैंने मिड स्पैन के ऊपर निकाला है एक्सेंट्रिसिटी. व्हाट अबाउट द एक्सेंट्रिसिटीज एट सपोर्ट? मतलब मैंने सब रब भी कर दिया वैल्यू अभी. एक्सेंट्रिसिटी एट सपोर्ट, एक्सेंट्रिसिटी मस्ट बी लेस देन और इक्वल टू, ये टर्म रहेगा, ये टर्म रहेगा, ये जीरो हो जाएगा. सो इट विल बी 466.09 minus 217. And eccentricity must be more than 0 plus, थोड़ा पीछे चला यार, मेरे को वैल्यूज मिलेंगी क्या? हाँ, so at support it is minus 217.39. ओके, ये कितना आया है? मस्ट बी लेस देन टू 248.68. ओके, 248.68 and must be more than or equal to minus 217.4. Minus 217.4. This minus only indicates it is on the other side. So it must be less than or equal to, because I will multiply with minus. So that will be on the other side. It must be less than or equal to 1 point above the neutral axis. That's all. This is what the minus indicates. If I multiply the whole equation with minus, it is minus E. The inequality will reverse. It will become positive. So negative eccentricity means it is on the other side. So support पर कहाँ रहना चाहिए? 217 ऊपर मैक्सिमम and नीचे 248. This is 217.4 and here it must be 248.66. And what about at mid span? At mid span it must be more than 460. So this is somewhere here 460 and must be less than or equal to, किधर है वैल्यू? 624. 560 था मैक्सिमम, इसका मतलब उसकी भी नीचे गया है, यहाँ है. This distance is 460.28 and this distance is 642.11. and now join these points. This is the safe cable zone. The cable has to lie within this limit. It is going outside of the section, no worry. हम वहां पर प्रोवाइड नहीं करेंगे. थेरोटिकली केबल वहां तक प्रोवाइड किया जा सकता है. थेरोटिकली वी कैन प्रोवाइड केबल देयर ऑल्सो, लेकिन प्रैक्टिकली ऐसा पॉसिबल नहीं है. सो दिस इज द वर्टिकल लिमिट विद इन विच द केबल इज टू बी प्रोवाइडेड. दिस इज कॉल्ड एज द सेफ केबल जोन. इज दैट ओके? So this is how the problems can be solved for rectangular section, for unsymmetric eye section. It is question number 4. It is making the question number 4. A post tension beam of span 15 meter. How much is the span? 15 meter. Question number 4 I am talking about. Overall depth is 900 mm. The overall depth is given as 900 mm. Uniform symmetrical flange cross section. Okay. It is a symmetric section. It has 2 into 10 raised to power 4 area. Area is equal to 2 into 10 raised to power 5. Sorry, mm square is the area. And second area moment, that is the moment of inertia actually. 212 into 10 raised to power 8 mm raised to power 4. Second area moment. Okay. The pre-stress is provided by a cable which is tensioned to a force of 1450 kN at transfer. The pre-stressing force provided is equal to 1450 kN. Okay. Beam has to support an imposed uniformly distributed load of 21 kN per meter. Imposed load is 21 kN per meter. The unit weight of concrete gamma C is given as 24 kN per meter cube. So whatever is given in the question, that is to be used. If not given, we consider 25 kN per meter cube. 24 दिया है, 24 यूज करेंगे. नहीं देता था 25 यूज करते थे. There is 20% loss, so the loss factor is 0.8. Calculate safe vertical limit within which the cable must lie along the length of the beam. तो हमको चाहिए safe cable zone. What is asked in the question is calculate the safe vertical limits in which the cable must lie along the length of beam. That is nothing but the safe cable zone. लीनियर क्यों नहीं? अच्छा, पहले में मतलब सर जो सेफ केबल जोन है वो हमेशा दो पैराबोलिक के बीच इनक्लोज क्यों रहता है? लीनियर क्यों नहीं? सी, बिकॉज मोमेंट चेंजेस नॉर्मली विद द because the curve of the bending moment is normally parabola. That's why it is. अगर सेल्फ वेट बहुत कम है और कॉन्संट्रेटेड लोड है तो फिर वहां पर लीनियर वेरिएशन रहेगा. तो वहां पर हम अज्यूम कर सकते हैं कि लीनियर रखेंगे. इज दैट ओके मुस्तफा? अदरवाइज नॉर्मली लोड का जो बेंडिंग मोमेंट रहता है वो पैराबोला था बिकॉज सेल्फ वेट रहता है. सो इट इज पैराबोला. एज इट इज पैराबोला, दैट्स व्हाई वी कंसीडर द कर्व्स एज पैराबोला. अगर लीनियर रहता है, कॉन्संट्रेटेड लोड है, सेल्फ वेट डोमिनेंट नहीं है, तो वहां पर हम लीनियर भी प्रोवाइड कर सकते हैं. When the self weight is very small compared to the imposed load, so in that case we can assume linear also. See, और ये जो ब्रिज है, ब्रिज में हमेशा सेल्फ वेट डोमिनेंट रहता है imposed load पर. अभी हमने देखा था the moment because of the self weight is more than the moment because of imposed load, right? तो सेल्फ वेट का इफेक्ट जो बेंडिंग मोमेंट आ रहा है पैराबोलिक का, उसके लिए हम नॉर्मली वी गो फॉर द पैराबोलिक केबल प्रोफाइल. और वो जो लाइंस है which we join for the limits, those are also parabola. Okay. Now come to this question. This safe cable zone. Permissible compressive stresses transfer and working are 14 and 16.8. So the permissible values of stresses in compression at transfer, permissible values of stresses in compression at working. ट्रांसफर पर कितना दिया है 14 और इस पर कितना दिया है 16.8 permissible stresses. The permissible tensile stresses transfer and working are 0. Permissible values of stresses at transfer are 0 and permissible tensile stresses at working are equal to minus 3.5. That's all. And what you are supposed to do here? Safe cable zone. अभी यहाँ पर हमको चेक द सुटेबिलिटी ऑफ टेप सेक्शन नहीं करना है, गेट द मैग्नीट्यूड ऑफ प्रीस्ट्रेसिंग फोर्स नहीं करना है, एक्सेंट्रिसिटी डिटरमाइन नहीं करना है. यहाँ पर हमको सिर्फ सेफ केबल जोन लोकेट करना है. Here you are only supposed to locate the safe cable zone. You can do this. I am not solving this problem. This I will consider as your homework. You can do this. How? Only you have to follow these two equations. Eccentricity must be less than or equal to. Do we have the value of Z available? It is a uniform symmetric section given. Uniform symmetric flanged section. अगर ये यूनिफॉर्म है, सिमेट्रिक है, फ्लैंज सेक्शन है, इसका क्या मतलब रहेगा? The ZB will be equal to ZT will be equal to Z and that will be equal to I upon Y. The moment of inertia is given 212 into 10 raised to power 8 divided by the overall depth is 900. So half of depth is nothing but 450 by the neutral axis is. So you can have the value of Z. The value of Z is available. The pre-stressing force is available. FCT is also given in the question. ZBA, all the things are available. Moment because of self-weight. The self-weight, the area is available. The unit weight is also given. You can have the self-weight. The span is available. You can have the moment because of self-weight. FTW, it is FTW is equal to minus 3.5. Eta loss factor is given as 0.8. MS, MI, ZB, all the things are available. You have to only put these values at mid span. Then you get at support and you will get a range within which the cable is to be provided, and that is nothing but the safe cable zone. I hope you can do this. Is that okay? Will it be alright? Can you do this? Okay, that I have replied. Okay. So I hope that this problem you can do. Determine the limits of the eccentricities at mid span and at support, and then draw the parabolic curves. That is the limit within which the cable is to be provided. Because the dominant bending moment curve is parabola, that's why the nature of curve will be parabola. I hope that you can do this. This is your homework problem. There is nothing new in this question. This question you consider as your homework and do it. Next we are moving to another question. It is question number 5. A pre-stressed beam has an unsymmetric I section. It is an unsymmetric I section. Okay. Overall depth 1840. The top and bottom flange widths are 1800 and 820 mm. Okay, this is 1820 and here it is 820. No problem. And this overall depth is 1840 mm. Okay. The thickness of top flange varies from 180 mm to 430 mm at the junction of the web. Okay. This is how it is. यहाँ पर कितना दे दिया उसने? The thickness of the top and bottom flange ये दे दिया. The thickness of top flange is 180 and it varies to 430. The thickness of top flange varies from 180 mm at ends to 430 mm at the junction of web. The thickness of bottom flange varies from 150 mm to at the junction it is 450 mm. Okay. The web is 180 mm thick. The web is 180 mm thick. Okay. It is the unsymmetric eye section, right, which is having tapered flanges. The beam is designed for a simply supported span of 80 meter. The span is 40 meter. The beam is designed for a simply supported span of 40 meter. Permissible compressive stress is limited to 16 MPa, where the tensile stress, transfer and working load is limited to 0 and 1.4. Okay. The permissible values of stresses in compression and transfer and at working are restricted to 16 MPa, whereas the permissible values of stresses in tension and transfer are 0 and at tension and working are equal to minus 1.4. It is given in the question. The loss ratio is 0.8. The properties of the section are: area is equal to 1016,500. The moment of inertia is 4442 into 10 raised to power 8 mm raised to power 4. Yt is equal to 700. Yb is equal to 1140. ओके, ये अच्छा किया है. एरिया दे दिया है. मोमेंट ऑफ इनर्शिया प्रोवाइडेड इन द क्वेश्चन. वैल्यूज ऑफ yb एंड yt प्रोवाइडेड इन द क्वेश्चन. इससे हमारा काम आसान हो गया. नहीं तो इसके प्रॉपर्टीज कैलकुलेट करने के लिए काफी टाइम जाता. टू गेट द एरिया ऑफ दिस टिपिकल सेक्शन, टू लोकेट पोजीशन ऑफ सेंट्रॉइड, टू गेट द मोमेंट ऑफ इनर्शिया, टू गेट द सेक्शनल मॉडुलस, उसमें हमारा बहुत सारा टाइम लॉस हो जाता था. बट in the question we are having sufficient data available. It is very helpful to us. So we are having the properties available. Now what you are supposed to determine? Permissible UDL. What is the permissible UDL on the beam? Okay, we will do one by one. What is next? The magnitude of the pre-staging force. If it is located at 130 mm from the socket of the beam at the mid-span section, the vertical limit within which the cable is to be provided at mid-span and support. ठीक है, we will do. पहले हम permissible UDL determine करते हैं. How we can determine the permissible UDL? I want the element to be safe. I want the ZT provided must be more than or equal to ZT required. ये सेफ रहेगा. I want ZB provided to be more than or equal to ZB required. अगर ऐसा है तो एलिमेंट सेफ है. Is that right? The provided values of ZB and ZT we can have from here. First we will determine the value of ZT required. How we can have the value of ZT required? From this equation, 1 minus eta ms. How much is the moment because of self-weight? Get the self-weight intensity first. How you can have the self-weight intensity? 1016,500. It is mm square. multiplied by 10 raised to power minus 6 meter square multiplied by the unit weight, it is 25. So get the self weight, get the moment because of self weight. The span is 40 meter. So tell me the self weight intensity, tell me the moment because of self weight. The unknown here is what is the safe imposed load. हम कितना imposed load रख सकते हैं. Okay, so will somebody please answer? What is the self weight intensity? How much is the self weight intensity? 25.4125. Thank you. 25.4125 kilonewton per meter. Now get the moment because of self weight. WL square by 8. $5082.5. Okay. 5082.5. So it is the moment because of self weight is equal to 5082.5. Okay. 5082.5 plus moment because of imposed load is unknown because the imposed load is not available. I will also consider that imposed load I will be putting here in terms of kilonewton meter. So it is multiplied by 10 raised to power 6 divided by. What about value of FTR? FTR is equal to FCW. That is 16 minus 0.8. What about value of FTT? FTT is 0. So I will get the value of ZT required. And if I want this element to be safe, then the ZT required must be equal to the ZT provided. How much is the value of ZT provided? I by Y. 4442 into 10 raised to power 8 divided by 700 and get the value of ZT provided. How much is the ZT provided? 4442 into 10 raised to power 8 divided by 700. So the ZT provided 634.75. 634.75 to 10 raised to power 6. So it is equal to 634.75 into 10 raised to power 6. Right? Equate it and get the value of imposed moment. How much is the imposed moment? Such that the sectional modulus provided at the top is just equal to the required value. I am calculating the imposed moment for the case when the sectional modulus provided is equal to the sectional modulus required. The provided is equal to required. I am equating the two, I will get the imposed moment. Similarly, I will do for ZB required. It is 1 minus 0.8 into 5082.5 plus MI into 10 raised to power 6 divided by FBR. It is 0.8 into permissible values of stresses in compression and transfer are 16 minus 0. And what is the value of ZB provided and required must be same. So that is nothing but ZB कितना रहेगा बताइए मुझे. I by Y. What is I by Y? 4442 into 10 raised to power 8 divided by Y. 1140. What is the value of ZB? 389.65. So it is equal to 389.65 to 10 raised to power 6. put here 389.65 into 10 raised to power 6. So in that case, what shall be the moment acting at the span or at the section? The impulse moment. The impulse moment in first case is 9136.62. 9136.62. And what about impulse load here or moment here? It is safe in limited state of serviceability cracking and maximum compression. So what must be the moment? 3971. Okay. 3971. 3971. Is that okay? 3971.02. Okay, thank you. So what do you think? Which of the two is correct? Or which of the two is the safe moment that can be provided? Safe moment कौन सा रहना चाहिए? If I want the top fiber to be safe, so in that case the moment that can be provided is equal to 9136. But if I want the bottom to be safe, in that case the maximum moment that must be acting is 3971.02. इसका मतलब अगर मैं 3971.02 प्रोवाइड करता हूं तो बॉटम और टॉप दोनों सेफ है. अगर मैं 3971.02 से थोड़ा भी ज्यादा प्रोवाइड करता हूं तो बॉटम अनसेफ हो जाएगा और टॉप सेफ रहेगा. सो द क्रिटिकल सेक्शन इज बॉटम. सो द सेफ मोमेंट इज 3971.02. Because if I provide any value greater than this, it will be unsafe here, though it will be safe for the top fiber. So the critical is bottom and the maximum moment that can be provided is 3971.02. So we will consider the movement because of imposed load as equal to 3971.02. So what is the safe load that can be provided? (3971.02) is equal to Wi L square by 8. That is the imposed load, because this is the moment because of imposed load. And you can have the safe imposed load that can be placed on the beam, 19.855. So it is equal to 19.855 kilonewton per meter. Is that okay? So this is this thing, right? क्योंकि बॉटम क्रिटिकल है, टॉप सेफ रहेगा. अगर और थोड़ा सा लोड भी बढ़ता है, मूवमेंट थोड़ा सा बढ़ता है तो सेफ रहेगा, बट बॉटम इज क्रिटिकल. ओके फाइन. नाउ अभी क्या दिया है क्वेश्चन में? द बी पार्ट ऑफ द क्वेश्चन इफ यू सी, इट इज मेंशन्ड हियर दैट बी पार्ट calculate the magnitude of pre-stressing force. Now the B part of the question, you are supposed to calculate the magnitude of pre-stressing force. If it is located at an eccentricity of 130 mm, if it is located at 130 mm from the soffit से 130 है, somewhere here the neutral axis is. How much this distance is? It is from the bottom 1140, and this cable is located at a distance of कितना बोलता है? 130 mm from the bottom. So how much is the eccentricity? Eccentricity will be equal to 1140 minus 130. So the eccentricity is equal to 1010 mm. Is it okay? Because what is given here? The cable is located at 130 mm from the soffit. If the cable is located at 130 mm from the soffit, you are supposed to calculate the magnitude of the pre-stressing force. See, how you can have the magnitude of pre-stressing? देखिए, how much is the imposed load acting? Imposed load का magnitude कितना था? Self weight का magnitude कितना था? How much was self weight? 25 point. What was the self weight intensity? How much was the self weight intensity? Self weight intensity I want, not moment because of self weight. It is self weight intensity. WS. 25.413. 25.413. And how much is imposed load it can carry? WI 19.855. मैंने क्या बोला था, जब ब्रिज का स्पैन रहता है, दिस इज वन ऑफ द ड्रॉबैक विद द ब्रिजेस, विद द हेवी गर्डर्स. In that case, the self weight of the element is more than the imposed load it will be carrying. This is one of the drawback with the bridges. जहां पर हमको बहुत हेवी गर्डर प्रोवाइड करना पड़ता है. गर्डर इतना हेवी रहता है कि उसका सेल्फ वेट इंपोज लोड पर डोमिनेंट हो जाता है. See here, the self weight is 25.413 and the imposed load it can carry is only 19.855. So self weight is more than imposed load. And do you remember पिछले प्रॉब्लम में मैंने क्या बताया था, जब सेल्फ वेट ज्यादा रहता है, इंपोज लोड कम रहता है, या मोमेंट बिकॉज ऑफ सेल्फ वेट इज मोर देन द मोमेंट बिकॉज ऑफ इंपोज लोड, इन दैट केस एक्सेंट्रिसिटी सेक्शन के बाहर चला जाता है, तो हमको एक्सेंट्रिसिटी को रेस्ट्रिक्ट करना पड़ता है. तो यहाँ पर हमको वो सब कैलकुलेशन से बचा दिया. क्वेश्चन में डायरेक्टली एक्सेंट्रिसिटी को रेस्ट्रिक्ट करके दे दिया है 1010 mm. And you are supposed to calculate the value of P. Now which equation you will use to calculate the value of P? क्योंकि यहाँ पर एक्सेंट्रिसिटीज को उसने एक्सेंट्रिसिटी को डायरेक्टली रेस्ट्रिक्ट कर दिया है, राइट? क्योंकि द वेट सेल्फ वेट इज डोमिनेंट ओवर द इंपोज लोड, द सेल्फ वेट इंटेंसिटी इज मोर देन द इंटेंसिटी ऑफ इंपोज लोड. तो हमको पता है ऐसे केसेस में एक्सेंट्रिसिटी सेक्शन के बाहर चला जाता है. देन वी नीड टू रिस्ट्रिक्ट द एक्सेंट्रिसिटी. और जब हम एक्सेंट्रिसिटी को रेस्ट्रिक्ट करते हैं, then we need to calculate the revised value of the pre-stressing force. What is that equation for the revised value of the pre-stressing force? F inferior A ZB divided by AE plus ZB. Is it right? This was the equation. Is it correct? We had developed this equation in our last class. इसके पिछला प्रॉब्लम में. So now you need to get the value of F inferior A ZB AE ZB. हमारे पास A का वैल्यू अवेलेबल है, ZB अवेलेबल है, एक्सेंट्रिसिटी रेस्ट्रिक्टेड अवेलेबल है. The only one you require is F inferior. Where you can have value of F inferior from here. So it is F inferior is equal to one divided by 0.8 FTW minus 1.4. It is given here FTW plus MS plus MI. The moment because of self-weight and imposed load is available 5082.5 plus 3971.02 into 10 raised to power 6 divided by ZB. What is ZB? ZB is available 389.65 into 10 raised to power 6. So get the value of F inferior, put here and get the value of pre-stressing force. Will someone give me the answer for the pre-stressing force? What is the pre-stressing force to be provided? Is it right? जितना क्वेश्चन में पूछा है उतना करने का. यहाँ पर प्री-स्ट्रेसिंग फोर्स, फिर एक्सेंट्रिसिटी, फिर बोलने का रिस्ट्रिक्ट किया, अंदर आता है, फिर एक्सेंट्रिसिटी, वो सब करने का जरूरत नहीं है, क्योंकि यहाँ पर उसने ऑलरेडी रिस्ट्रिक्ट करके दे दिया है एक्सेंट्रिसिटी. द एक्सेंट्रिसिटी इज रिस्ट्रिक्टेड सच दैट इट इज लोकेटेड एट 130 mm फ्रॉम द बॉटम. और मैंने इंपोज लोड और सेल्फ वेट के इंटेंसिटीज पता है. सो द इंटेंसिटी ऑफ इंपोज लोड इज लेस देन द सेल्फ वेट. तो हमको समझ में आ गया कि एक्सेंट्रिसिटी बाहर जा रहा है, उसको रेस्ट्रिक्ट किया है. Then this is the only equation to use the magnitude of the pre-stressing force. Get F inferior, put in the equation, get the pre-stressing force. So it is 27.296. 27.296 MPa Put everything here in the equation, get the pre-stressing force. Seven six three 1.78. 7631.78. Is it okay? Is it right? Will someone please confirm this? Okay, fine. Thank you, Mr. Mayur. So this is how self-weight can be, and the imposed load can be determined, the pre-stressing force can be determined. Now the C part of the problem is to locate the safe cable zone. I hope you can do that part, that you consider as your homework. These are the two equations. You will get the limits of the eccentricities, locate the safe cable zone and do that. Now the next is question number 6. The question number 6 is, the remaining that C part you can do, that is your homework. Locate safe cable zone. The cross-sectional area of an unsymmetric I-beam designed to carry a central point load on a simply supported span. That's question number 6 and 7. There are only 2 questions remaining. अगर मुझे आधा घंटा या 40 मिनट देंगे तो वी कैन फिनिश दिस 2. ये क्वेश्चन कर लेंगे बेटे. Question number 6 we will do. The cross-sectional area of an unsymmetrical I-beam designed to carry a central point load on simply supported span. It is unsymmetric I-beam. It is supposed to carry a central point load on a simply supported span of 15 meter. The area is 194,000 mm square. The second moment of, that is nothing but the moment of inertia, is equal to 197 into 10 raised to power 8 mm raised to power 4. The overall depth of the section, okay, the overall depth of the section is 900 mm, which is with centroid located at 520 mm from the socket of the beam. It is the unsymmetric I section. The centroid is located at 5, so that is nothing but actually YB I will write 520 mm. FCW is equal to 40 and FTT is equal to FTW is equal to 0. Okay. Loss ratio is 0.8. Okay. Calculate the breadth of a rectangular section. Calculate the breadth of a rectangular section having same depth and same minimum sectional modulus as of I section. Now, you are supposed to consider a rectangular section which is having same depth, but what must be the width, such that the minimum sectional modulus here What is the value of ZB and what is the value of ZT? It is I by ZB and I by ZT. It is 197 into 10 raised to power 8 divided by 520. It is 197 into 10 raised to power 8 divided by 480. Because if it is 520, the value of YT will be 480. So get the value of ZB and ZT. Which of the two is minimum? See, the numerator is same, the denominator here is 520. So the minimum is ZB. So whatever is the minimum sectional modulus, the rectangular section is also having the same sectional modulus as it is given here in the question. What is mentioned in the question? Please read the question. The question is, the cross-sectional area of an unsymmetric I-beam designed to carry a central point load on a simply supported span of 15 meter. It is a simply supported span of 15 meter. There is a central point load. It is an unsymmetric I-beam. 15 meter is the span. The area is 194,000 mm square. The second moment of area is equal to 197 10 raised to power 8 mm raised to power 4. The overall depth of the section is 900 mm. Which centroid is located at 520 mm from the soffit. So the centroid is located at 520 mm. From the soffit, so from the extreme top it is 480 mm because the overall depth is 900. Consider FCT is equal to FCW is equal to 40, FTT is equal to FTW is equal to 0, the loss ratio is equal to 0.8. This is the data given in the question. Now what you are supposed to determine? You are supposed to determine the breadth of a rectangular section having same depth and same minimum sectional modulus as of I section. The depth is same for the rectangular section. Now it is a rectangular section having the same depth as the I section. It is 900, so this is also 900. And what must be the value of width? Width हमको कैसे determine करना है? It is such that the sectional modulus of the rectangular section is equal to the minimum sectional modulus of I section. This is the sectional modulus corresponding to bottom, corresponding to top. The numerator is same, the denominator is different. More the denominator, lesser will be the sectional modulus. So this is the minimum sectional modulus. So the sectional modulus of the rectangular must be equal to the minimum. So it is 197 into 10 raised to power 8. Or what is the value of this ZB? How much this ZB is? You tell me this value of ZB. 197 10 raised to power 8 divided by 520. Give me the value of ZB and ZT. What is the value of ZB and ZT? For I section. $37.885. It is 37.885 into 10 raised to power 6. And what about ZT? थोड़ा ज़्यादा रहेगा. थोड़ा सा ज़्यादा रहेगा. $41.042 is equal to 41.042 into 10 raised to power 6. The minimum sectional modulus is this. The rectangular section must have the sectional modulus equal to the minimum sectional modulus of the I section. So it is B square by 6 is the sectional modulus must be equal to 37.885 into 10 raised to power 6. Is it right? The rectangular section must have same depth as the I section. You are supposed to determine the width of the rectangular section such that the minimum sectional modulus of I section and the sectional modulus of the rectangular section are equal. So what must be the width? How much must be the width of the rectangular section? How much it will be? BD square by 6, the sectional modulus of rectangular section. .63, so it is equal to 280.63 mm. Fine. So one part of the question is solved. You are supposed to determine the width of the section such that the sectional modulus of rectangular section is equal to the minimum sectional modulus of unsymmetric I section. What is the part B? The value of safe central point load for rectangular and I section. Say the magnitude of this concentrated load is I, which is acting at the center. If I want this rectangular section to be safe, what is the value of W? If I want this I section to be safe, then what is the value of W? How this we can do? क्या करना पड़ेगा हमको? If I want this section to be safe, when the load W is acting, so I have to verify that ZB provided. How much is the ZB provided? That is 37 point ZB provided must be more than or equal to ZB required. How much is the ZB provided? 37.885 must be more than or equal to. What is the value of ZB required? 1 minus eta. Eta कितना है? 0.8. MS plus MI. Now get the value of self-weight intensity, get the value of movement because of self-weight. For rectangular section, how much is the area? Area of rectangular section will be 280.63 multiplied by 900. So how much is the area? What is the area? If you know the area, get the self-weight intensity. Then get the moment because of self-weight. I want it to be safe. 252567. So area is equal to 252567. So what is the self-weight intensity? mm square multiplied by 10 raised to power minus 6 meter square multiplied by unit weight 25. Get in kilonewton per meter. Span is 15 meter. W square by 8. Get the moment. .314. Thank you. It is 6.314. And what is the moment? This is kilonewton per meter. Moment is 177.58. 177.58 kilonewton meter. Okay, done. So now, if I want bottom to be safe, it is MS 177.58 plus MI is unknown because this imposed load is not available. I assume that I will be getting that in kilonewton meter. So 10 raised to power 6 divided by. What is this FBR? The range of stresses corresponding to bottom fiber, FBR. What is value of FBR? FBR we can know from this equation, eta. Eta is 0.8. FCT. permissible values of stresses in compression and transfer 14 minus FTW is 0, so it is minus 0. Get the value of MI. MI must be less than or equal to. If I want the top fiber to be safe for safety of top fiber, ZT provided must be greater than or equal to ZT required. How much is ZT provided? It is a rectangular section, so the ZT and ZT must be same. So it is 37.885 into 10 raised to power 6 must be greater than or equal to 1 minus eta into 177.58 plus MI divided by 10 to 10 raised to power 6 divided by. What about FTR? FCW. FCW is 14 minus 0.8 into 0. So get the value of MI. MI must be less than or equal to. If I want bottom to be safe, this is the maximum movement. The movement must be less than or equal to this. If I want the top fiber to be safe, movement must be less than or equal to. So the lesser of the two values we have to consider as the safe movement that can be kept on the section. So give me the values of MI corresponding to the bottom and top fiber. So I will get what is the concentrated load that we can keep if it is a rectangular section. So what is the value of MI corresponding to the bottom fiber? कौन आना चाहिए आपको क्या लगता है? Which is critical? The bottom is going to be critical क्योंकि वहां पर denominator is less 0.8 into 14. So give me the value of MI corresponding to the bottom and corresponding to the top fiber. For safety of bottom fiber, for safety of top fiber. Corresponding to top. अच्छा, पहला है 388.79 corresponding to bottom 388.79 kilonewton meter, and corresponding to top 494.87 494.87. So which of the two I will consider as the same moment to be placed? One which is corresponding to top or to the one which is corresponding to bottom? The lesser of the two we have to consider. So which is the safe moment that we can keep on the section? Which of the two moments we can consider as the safe? Acha, very good. 103.68 kilonewton is the load, and that must be corresponding to 388.79. Is that right? 388.79. You get the lesser, right? Bottom safe. Okay, good. So one which is corresponding to the bottom, this is critical. हम इससे ज़्यादा मोमेंट नहीं रखना चाहिए. If I keep movement more than this, यहाँ पर फेल हो जाएगा, यहाँ तो सेफ रहेगा 494 तक. So it is critical. Now corresponding to this, you get the magnitude of the concentrated load. The magnitude of the concentrated load is equal to WIL by 4. So get the value of W because it is a concentrated load, the imposed load, and that is to be 103.68. So it is 103.68 kilonewton. So what we can conclude here is, if it is a rectangular section, the concentrated load that we can keep at the section is 103.68 kilonewton. Right? What was that B part of the question? You are supposed to compare. Part A में तो सिर्फ बोला था कि you determine the width of the rectangular section such that the section modulus of rectangle is equal to the minimum sectional modulus of I section. So we have determined that width. Second part of the question was you are supposed to determine the value of safe central point load for rectangular and I section. अभी I section के लिए हमने determine किया है, rectangular के लिए determine किया है. Now we will be determining for the I section. How we can determine it for I section? अभी यहाँ पर भी क्या होना चाहिए? It must be safe in bottom and top. If I want the I section to be safe in bottom and top, so first we are solving for bottom. The sectional modulus provided is 37.885 into 10 raised to power 6 is equal to, so here must be more than or equal to 1 minus eta. MS. How much is the moment because of self-weight? The self-weight is available. The area is available. Get the self-weight intensity, get the moment because of self-weight. Area is 194000. But how much is the self-weight? The self-weight is 4.85. It is 4.85 kilonewton per meter, and the moment is 136.41. It is 136.41. Okay, done. Kilonewton meter. So 1 minus eta ms. It is 136.41 plus mi unknown into 10 raised to power 6 divided by. What is the value of FBR? It is corresponding to the bottom. For the safety of bottom we are talking about 0.8. It is 14 minus FTW 0. So get the value of mi. Mi must be less than or equal to. Then for safety of top fiber, it is 41.042 into 10 raised to power 6, because this is the section modulus corresponding to top, must be more than or equal to 1 minus 0.8 into 136.41 plus mi into 10 raised to power 6 divided by. What about FTR? FCW 40 minus 0.8 into 0. So mi must be less than or equal to. Now tell me the two values of mi here also. The lesser of the two moment we will keep on the I section because of imposed load. So mi 397.03, is it corresponding to top or bottom? 397.03 kilonewton meter. Is that corresponding to top fiber or that is corresponding to bottom fiber? Sir, video freezed. Okay. Is it freeze? Is it freeze? No. It is not freeze. It is all working. Okay. So that value of moment is how much? 397.03. Working. Thank you. अच्छा, corresponding to top कितना है? 547.3. 547.3. 547.3. And corresponding to bottom is 397.03. So it is 397.03. So which of the two we will consider as the safe moment that can be placed on the section? 397.03. This is the moment, right? Because this is the lesser value. मूवमेंट इससे कम रहना चाहिए, मूवमेंट इससे कम रहना चाहिए, फॉर द बॉटम टू सेव, फॉर द टॉप टू सेव. So the movement must be lesser of the two, so that top and bottom both fibers will be safe. So the movement that we can keep on the section is 397.03. So the safe moment is 397.03. This is the safe moment is equal to Wi L by 4. So what must be the imposed load? (105.88). Okay. So the imposed load we can keep here is 105.88 kilonewton. See what can be concluded. अगर आप देखते हैं, if you compare the two, a rectangular section and a I section, it is of same depth, it is of same minimum sectional modulus, right? All other properties are same, with the permissible values of stresses, the loss factor and all. The imposed load that we can keep in case of the rectangular section is 103. The imposed load that we can keep at the center when it is the I section is 105.88 kilonewton. So which of the two is preferable? दोनों में से हमने कौन सा प्रीफर करना चाहिए? Rectangular section, the safe imposed load that we can keep is 103. For same limit of the permissible values of stresses, for same loss factor, same depth, same minimum section modulus, the rectangular section can carry a central point load of 103, whereas the I section can carry 105.88. So what do you suggest? If the option is given to you, what to prefer? Which section is to prefer? Rectangular section. Why so? Why will you prefer a rectangular section over a I section? Both the sections are safe. Right? If I want I section to be safe, the maximum load it can carry is 103.68. When the I section is safe, it is carrying 105. तो I section safe है 105 पर, rectangular section safe है 103 पर. तो दोनों में से कौन सा सेक्शन सेफ रहेगा? Right, the I section is carrying greater load. It can carry greater moment. It is having greater capacity. Is that right? Yes. That's why we will prefer I section, because it can carry greater magnitude of load. Rectangular section 103 पर safe है, I section 105 पर safe है. So I will prefer I section because that is carrying more load, right? The second thing is I section is economical. How do you know that the I section is economical? Mustafa is right. I section is economical. But how you know that the I section is economical? Yes, lesser is the area. Lesser is the area required. Lesser is the material required. Lesser is the scaffolding required. Lesser is the workmanship required. So it will be economical. What is the percentage economy you can say? If you will compare the area of I section is 19400. The area of rectangle section is 252567. And that is what the third part of the question is. If you will see the third part of the question, the saving in steel and concrete in I section compared to rectangular section. So rectangular section we have to make base, and in reference to the rectangular section we have to compare the economy. See how we can have the economy in concrete, the saving in concrete. How we can have saving in concrete? If you want to have the saving in concrete, the area, the cross-sectional area required, take the difference, 252567 minus 194,000 divided by 252567 multiplied by 100. It is the percentage saving in concrete. Difference of the two area, divided by the area of rectangle, because you are supposed to compare with the area of rectangle as it is given in the question. Determine the percentage saving in steel and concrete comparing to the rectangular section. हम I section में कितना परसेंटेज सेविंग कर रहे हैं रेक्टेंगुलर सेक्शन कंपैरिजन में. So the base is rectangular section. Difference of the two area divided by the base area, that is the area of the rectangle, because we are supposed to compare with the area of rectangle, multiplied by 100, and I will get the percentage saving in concrete because the length is same. जितना cross sectional area में difference है उतना ही volume में difference रहेगा. Because the length is same, that is going to get cancelled only. So how much is the percentage saving in concrete? 23.19. You are right. So this is equal to 23.19% saving. I section थोड़ा सा लोड ज्यादा भी कैरी कर रहा है, ये 103, ये 105. ठीक है, it is carrying more load, better. Second, the percentage saving is also there. The area is less, the area is more. कितना 23%, it is considerable. तो हमको कंक्रीट में बहुत सारा सेविंग हो रहा है. Now, how to get the percentage saving in steel? This is the percentage saving in concrete. How to get the percentage saving in steel? How will you get the percentage saving in steel? For I section and for rectangular section. This is for I section, this is for rectangular section. Get the value of P. Get the value of P here. जितना pre-stressing force रहेगा, the initial stresses will be same. So if the initial stress is same, you know the pre-stressing force. You can have the area of steel required. यहाँ पर कितना area of steel चाहिए, वहाँ कितना steel चाहिए. Get the difference, and you will have the percentage saving in steel. How will you determine the value of P required here for I section? It is A 1944000. ZB, क्या आपको ZB का वैल्यू अवेलेबल है? गेट द वैल्यू ऑफ F इंफीरियर. आपको सब फॉर्मूले पता है F इंफीरियर वगैरह के सब. प्लस ZT F सुपीरियर डिवाइड बाय ZB प्लस ZT. तो यहाँ पर आपको P ऑफ I सेक्शन मिल जाएगा. Similarly, can you get the value of P for rectangular section? Now, P for I section difference, P for rectangular section divided by P for rectangular section multiplied by 100, and you will get the percentage difference in the pre-stressing force. That percentage difference is nothing but the percentage difference in the area of pre-stressing steel required. That is nothing but the percentage saving in steel. That's all. तो आपको प्री-स्ट्रेसिंग फोर्स कैलकुलेट करना पड़ेगा. यू आर हैविंग द फॉर्मूला अवेलेबल. आई सेक्शन के लिए कैलकुलेट कीजिए, रेक्टेंगुलर सेक्शन के लिए कैलकुलेट कीजिए. टेक द डिफरेंस डिवाइडेड बाय द प्री-स्ट्रेसिंग फोर्स रिक्वायर्ड फॉर द रेक्टेंगुलर सेक्शन बिकॉज दैट इज द रेफरेंस, मल्टीप्लाइड बाय 100, and you will have the percentage saving in steel. Is that okay? So I think this is all sufficient for today. We are having just one question left, और उसको मुझे एक आध घंटा देना पड़ेगा. 1 घंटा या इवन आधा घंटा will be all sufficient. लेकिन we have to discuss many things in that. So that we will do in next class, I think. Will it be okay? एक क्लास और लेना पड़ेगा, and that will be for just 1 hour. That will be all enough. Right? So that one question we will do in the next class. Is that okay? That one question we will do in next class. This whatever remaining part of the question, I can assume that this will be your homework and you can do that. And for the internal assessment test 2, IAA 2, whatever portion was covered in IAA 1, excluding that part, the entire syllabus is there in IAA 2. हमने IAA 1 में क्या कंसीडर किया था? एनालिसिस. That was the chapter 1 was the introduction, material, technology. Chapter 2 was analysis. Chapter 3 was losses in pre-stress. तो ये 3 चैप्टर को एक्सक्लूड करके what is remaining? Deflection, shear, flexure, and this design. These 4 topics will be there in the internal assessment 2. Is it okay? And weightage will be almost equal for all the topics. Topic 1, that is deflection. अगर 20 क्वेश्चन रहते हैं तो 5 क्वेश्चन will be on deflection, 5 will be on shear, 5 will be on flexure, and 5 questions will be on this design. So it will be entire syllabus now. बहुत मुश्किल नहीं रहेगा. मैं आपको एक ट्रायल टेस्ट पेपर देता हूँ कल या परसों. What is tomorrow? Tomorrow is Wednesday. So I will give you one test paper for practice purpose. You will have an idea कि हमारा डेप्थ क्या होना चाहिए स्टडी का, right? But whatever is the remaining part that we will consider entire, that will be better for you. You will have a practice. तुम सॉल्व नहीं कर रहे हो. We have done sufficient number of questions. मैंने आपको इतने क्वेश्चन क्लास में सॉल्व कराया है कि अगर आप बहुत अटेंशन से अटेंड किए होते तो यू वुड हैव गॉट ऑल द कांसेप्ट्स क्लियर. बहुत डेप्थ में हमने सॉल्व किया है. और तुम लोग की तरफ से आई एम नॉट एट ऑल हैप्पी विथ यू बिकॉज मेनी ऑफ यू हैव नॉट सबमिटेड द असाइनमेंट्स. दिस इज टू मच. अगर मैं अपने किसी एक्टिविटी में बहुत बिजी हूँ, इट डजंट मीन दैट यू विल नॉट कंट्रीब्यूट फ्रॉम योर साइड. बच्चों, पढ़ना तुमको है, सीखना तुमको है, कंसेप्ट जानना तुमको है, एग्जाम तुमको देना है, फ्यूचर में मार्केट में तुमको जाना है. यू हैव टू प्रूव योरसेल्फ इन द मार्केट. सो यू मस्ट गेन नॉलेज. आपने सॉल्व करना चाहिए, सीखना चाहिए, डू प्रैक्टिस. अभी छोटे बच्चे नहीं है कि मैं आपको ये सब समझाऊं. So please solve questions, do practice. If you are having any doubt, ask me in that WhatsApp group we are having, either there or personal. I will reply. Don't worry. Right? मैंने जितने क्वेश्चन सॉल्व कराया है वो बहुत है. In addition to that, मैंने आपको क्लास वर्क का भी शीट दिया है. वो क्लास वर्क के क्वेश्चन सॉल्व कीजिए. In addition to that, मैंने आपको असाइनमेंट दिया है. वो असाइनमेंट सॉल्व कीजिए. You are not doing assignment क्योंकि असाइनमेंट में भी मैंने कुछ ट्रिकी क्वेश्चन रखा है. अगर आप वो सॉल्व करते हो सेल्फ, अगर सेल्फ सॉल्व नहीं कर रहे हो, भाई यू डिस्कस अमंग द फ्रेंड, देयर इज नो हार्म इन दैट, बट सिंपली डोंट कॉपी इट. देयर इज नो मीनिंग इन दैट. अगर आप सिर्फ कॉपी कर ले तो इट इज नॉनसेंस. असाइनमेंट देने का पर्पज है यू मस्ट डू प्रैक्टिस. यू आर हैविंग सफिशिएंट टाइम. बहुत टाइम दिया है मैंने. असाइनमेंट बहुत सारे तो 1 महीना पहले, 1.5 महीना पहले भी दे दिया है, लेकिन कुछ स्टूडेंट ने अभी तक भी सबमिट नहीं किया है. योर इंटरनल मार्क्स विल बी इंटायरली बेस्ड ऑन योर डेडिकेशन, बेस्ड ऑन राइट योर सिंसियरिटी, योर पंक्चुअलिटी. सो प्लीज सबमिट द थिंग्स इन टाइम. ओके, मैं तुमको कल एक टेस्ट पेपर दे रहा हूँ, उसको भी टाइम बाउंड रखूंगा, लेकिन इट विल बी फॉर जस्ट 1 आवर. मुझे टाइम बताइए व्हाट टाइम इज कन्वीनियंट, लेकिन इवनिंग आवर्स रहेगा क्योंकि मॉर्निंग में मैं दिन में कॉलेज में रहूंगा. तो इन द इवनिंग आवर्स आफ्टर 8 इट विल बी फॉर 1 आवर, 20 क्वेश्चंस. इट विल बी अ टेस्ट पेपर बेस्ड ऑन द एंटायर सिलेबस, व्हाटएवर रिमेनिंग, excluding first those 3 topics which were covered in internal assessment 1. Okay, ठीक है, थैंक यू.